This is lesson 82, pages 166 and 167, and I believe we're finishing up our lessons on trigonometry. We're going to be finding trig ratios using some of the things that we've already done. Okay, we've used our trig values in a couple of other lessons, so just to review, we know SOHCAHTOA gives us our relationships. And in this case, you're not going to be given a picture, but you're probably going to want to draw a picture. That's going to help quite a bit. I'm visual. I like that. And let me show you the type of problem that we're talking about. Number one, it says find the sine of theta if the cosine of theta is 24 over 25. Okay, sounds kind of complicated, and I would suggest when you draw a picture, just draw you a generic triangle, and I would turn it the same way every time. I'm going to turn my triangle. I'm going to put my right angle in this right-hand corner every time. To me, it makes it a little bit more consistent and a little bit easier when you're working it. And I'm going to put my theta here every time. Now, look what it's saying. It's very similar to the last lesson. It just didn't give you the picture. So it says find cosine of theta. So we'll go ahead and put sine of theta over here equals, and this is what we're looking for. It says if the cosine of theta is 24 or 25. So we're kind of going to go backwards. If the cosine of theta is the adjacent leg over the hypotenuse, let's translate this information into this. So let's look at our triangle. We've got theta here. To theta, we've got the adjacent leg here, we've got the opposite leg here, and we've got the hypotenuse. So in this case, if 24 is the adjacent leg, then that would make this the 24. And if the 25 is on the bottom, that's the hypotenuse. Now, do we need to do the Pythagorean theorem? Let's see. To do sine of theta, we need the opposite leg over the hypotenuse. So I know the hypotenuse already is 25, but I don't know the opposite leg. I'm going to use just like I did in lesson 81. I'm going to let x be the side I don't know, in this case a leg. So I'm going to do leg squared plus leg squared equals hypotenuse squared. So x squared plus, and I believe that is 576, I think. Let me get my calculator. That's 576 equals, and 25 squared I know is 625. We'll subtract our 576. And I didn't give you any that won't come out even. So when I do 625 minus 576, I get 49. So that makes x equal to 7. Now I can do the sine of theta because I need the opposite leg, which is now the 7, over the hypotenuse, which I was given, and it's in lowest terms, and there's my answer. Number 2. We're going to find the cosine of theta if the tangent of theta is 3/4. So again, I'm going to draw the same triangle. I think if you change them up, I think it's more confusing. I think it's easier if you just sketch you a triangle and use it the same way every time. I'm going to put the theta in the same corner because they don't give me a picture. I can draw the picture anywhere I want to, and I think it's just easier to be consistent with this because that way, if this is your theta, this is your adjacent leg, this is your opposite leg, and this is your hypotenuse. Now let's review. What is tangent? Tangent is the opposite leg over the adjacent leg. So go back to my theta. So the tangent of theta is opposite leg over adjacent leg. Okay, it's pretty easy. Now we want to find cosine of theta. Cosine is going to be the adjacent leg, which I already know, over the hypotenuse. So that's the only one I don't know. This one may be one you remember. If not, still setting it up, going through the arithmetic. We know leg squared plus leg squared equals hypotenuse squared. 16 plus 9 equals x squared. 25 equals x squared. So x equals 5. So in this case, my adjacent leg to theta is the 4, and the hypotenuse is 5. And that one's in lowest terms. Sometimes they will be, sometimes they won't. In that case, they both reduced very easily. So take what you know, label it on the picture, and then take that Pythagorean theorem to get the other answer.